Good day everyone. Here's our math challenge for today. And here's our question. Solve for the value of x given this equation. X raised to 6 plus x raised to the fourth power plus x squared equals 16,275. Given that x is a real number. Now, if you want to try this problem, you can pause this video. You have 20 seconds and timer starts now. Time's up. Now let's answer this question together. First question is, how do you answer this kind of question? My first step to answer this problem is to focus on the constant term, which is 16,275. I know this is factorable because it ends with 75. And if a number ends with 75, surely it is divisible by 25. Now, if we divide this number to 25, we get 25 times 651. Now, factor out 651. This will give us 3 times 271. So, 16,275 is just 25 times 3 times 217. Now, if I can factor the right-hand side of this equation, so maybe we can also factor out the left-hand side of this equation. Now, let's try. Now, let's factor out the obvious factor, which is x squared. So, we have x squared times x raised to the fourth power plus x squared plus 1. Now, how do we factor x raised to the fourth power plus x squared plus 1? First thing to do is to subtract and add x squared. So, if we do that, x squared plus x squared is just 2x squared. And take note that x raised to the fourth power plus 2x squared plus 1 is a perfect square trinomial, and this can be factored as x squared plus 1 raised to 2. Now, we have a square number minus a square number, so we can apply the difference of two squares. If we have a squared minus b squared, it is equivalent to a minus b times a plus b. Therefore, x squared plus 1 squared minus x squared can be factored as x squared plus 1 minus x times x squared plus 1 plus x. Now, here comes the observation part. Take note that we have a perfect square factor on the left-hand side. And on the right-hand side, we also have a perfect square factor, which is this 25. We know 3 is a prime, 217 is also prime. So the only perfect square number on the right-hand side is this 25. Therefore, we can say that x squared is equal to 25. Now, get the value of x, get the square root on both sides. So x equals positive or negative square root of 25. Thus, this will give us the value of positive or negative 5. Now, we can say that x must be positive or negative 5. But this is not enough. So, let's use another method to see that x equals 5 or x equals negative 5 is the only real solution to this equation. Now, what we need to do is to equate this equation to 0. And then, let's try to factor out this polynomial using the method that we know. We can use synthetic division, factor theorem, and so on and so forth. And then, after factoring this equation, we get that the factor of this equation must be x minus 5 times x plus 5 times x raised to the fourth power plus 26x squared plus 651 equals 0. Now, x minus 5 equal to 0, we get x equals 5. X plus 5 equals to 0, we get x equals negative 5. And this factor, this will not give us a real value for x. So using discriminant, we can see that the value of the discriminant is less than 0. Therefore, this factor will not give us a real value for x. Therefore, sure enough that the only real value for x in this equation must be x equals positive 5 or x equals negative 5. And as always, we are done.